Okay, welcome everyone. So let's look at the first category of hydrocarbons that we are going to look at in organic chemistry. We already noticed that actually hydrocarbons are of three groups, and those three groups are the ones that we are going to focus on: the alkanes, the alkenes, and then the alkynes. Those are the three categories of the hydrocarbons that we're going to look at. So we are looking at the first, and in this session, we're going to look at a number of things regarding the alkanes. Of course, we want to know what they are. Okay, what are their physical and chemical properties? How can we manufacture, for example, methane in the laboratory? And then after that, we'll look at the uses, but also something very important that we shall look at is the nomenclature, the naming of these alkanes. What rules do we have to follow? Okay, yeah, so let's basically start. You can notice in this image here that you have a single bond between carbon and carbon, and this is basically characteristic of the alkanes, and that's why we have that picture there. So because of the single bond, we call them saturated. Alkanes are saturated and they have a general formula like that. The interpretation of this general formula is that you can have, if this n, if that n is 3, that means you have this H to n, right? That's what we are meaning there, plus 2. Okay, so if n is equal to 3, then we shall have C3 H, this 2 times the 3, that would be 6, plus the 2, right? So this will basically give us CH3 H8. Okay, so let's try to draw the structure formula for this and see what happens. So basically it is easier to start with the carbon atoms, because they are 3 and they have single bonds. So for the carbon atoms to be complete, they need to form at least 4 bonds, right? 4 bonds. So here it needs 3, here it needs 2, here it will need 3 to form 4. So you have H, 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 H. So how many hydrogen atoms are those? 1, 2, 3, 4, 5, 6, 7, 8. How many carbon atoms do you have? 1, 2, 3. So 3 here. Okay, so that is what we mean by this general formula. Okay, so that is that compound is actually called propane. It's called propane. 3 carbon atoms, propane, and then this suffix there comes in. Okay, we shall look at that. Okay, so sometimes they are called the paraffins because of the saturation, indicating their low reactivity. So they are not really very reactive compounds. So nomenclature, we saw this, we say that is about naming. So what rules do we follow in naming the different alkanes? Okay, the alkanes is one of the homologous series that we talked about earlier on, right? So in that group, you have different compounds that fall to it. You have different members. the members of the alkanes are very many, and they are different because of the different number of carbon atoms that they contain. So that naming is universally agreed upon, and that's, if you see this naming, especially in chemistry, we are referring to the conventional way of writing the names. For example, in this case, we are basically focused on organic compounds. How are they supposed to be named according to the international standards, or according to the International Union of Pure and Applied Chemistry, which is base. Okay? So rule number 1 is that the ending should have this suffix ANE. Okay? So we have methane, we have methane, we have ethane, we have propane, we have butane, we have pentane. Okay, so the moment you see that, you just know we are talking about an alkane. Okay, and now then we have the prefix that tells us about the number of carbon atoms. So this means 1, means 2 carbon atoms, maybe 3, but, 4, pent, 5, and others, by the way. Okay? So that is one rule that you need to know. That if they end with that suffix, then it is an alkane. Now we need to know what? We need to know how many carbon atoms are there. Because if we know the carbon atoms, if we know the group it belongs to, then we can do the structure. Just like what I drew here, this the structural formula, how it looks like. Okay? So that explanation is if things are actually straight. If they are straight, you go back here. This is straight, right? But you can also have branched hydrocarbons or branched alkanes. That means that it's not straight, you have other going like this, others going downwards, and things like that. So if we have some branching, then there are also some rules to follow. So what are those rules? So the long unbranched, they are the ones that we have just looked at, butane, pentane, and things like that. When you have a branch, so for example here, do you see that this group is not on the same line? It's not a long chain, it's a branch, it has a branch, right? So when you have a branch, what do? You number the carbon atoms starting from the end nearest to the substituent group. The end nearest to the substituent group. So the nearest end is here. The nearest end to the substituent group. Okay? So, and then the other thing is you give the name of the branch off. That branch off here has a name. In this case, it is the methyl because it has 1 carbon. If it is 2 carbon atoms, like this one, this is 1, and this is 2, then it is ethyl. Okay? And then now you can come up with the position of where that branching has happened. So that numbering, the concept of numbering comes in. So if you start from the nearest, from the point of branching, so this becomes carbon 1, carbon 2, carbon 3, carbon 4. Okay? So that means if you want to tell us that this is the methyl group that branched off from carbon 2, so you need to start with the position. This is not by accident that we have 2 methyl pentane. No, it's not by accident. So this is the position which we have got, the position of the branch, which is here. it is at carbon number 2. And what has branched is the methyl. So it is here. How many carbon atoms do we have? There are 5 because of the pent. 5. So we have 1, 2, 3, 4, 5 carbon atoms. So that is 2-methyl pentane. That's the name of this compound. Okay? Now, the rules don't end there. There are other rules to follow, especially for branched hydrocarbons. And in this case, we're talking about the branched alkanes, right? Yes. So, in our first case, it is only the branching off is only here. It's only here. Okay? So this is the compound that we looked at earlier on. Now, what if we have a branching, let us say, here, which is also similar to this. So this is another carbon with 3 hydrogen atoms. So we have this methyl group, this methyl, and then you also have that methyl group there. So we have 2. So in our naming, it has to come out that there are 2 groups that have branched off from this position and that position. So in this case, you have this one. If you remember, the same rules apply there. So if you're going to start counting from here, this is carbon 1, carbon 2, carbon 3, carbon 4. Okay? So the position of the groups are in 2 and that. So you're going to say you have 2, the position of the methyl group, and another position of the methyl group, which is 3, then dash, and then you have now what we call a prefix. That prefix means the number of the groups that we are talking about. The moment you have more than 1, you need to indicate whether it is di, if there are 2 groups that have branched. If it is tri, that means 3 groups have branched. And you need to indicate the positions of those, where those groups have branched from. Okay? So that's why we have this way have been, or it has moved. Yes, come here. So 2, 3, dash, dimethyl. Di because there are 2. 1, 2, methyl. So how many hydrogen atoms? They are still, are they still 5? They have increased by this with 1, 2, 3, 4, 5, 6. Xn. This Xn means 6. So that is what we are saying, that the carbon atom is branching away at carbon 2 and also branches there at carbon 3, but those branches are, both of them are methyls. If we have an ethyl group, that means we have one of the groups is having 2 hydrogen atoms. Ethyl. The naming is going to, if this group is ethyl and this one is methyl, which one comes first depends on the alphabet. This one. That is rule number 5. So if this one is ethyl, then you say, if actually this one is ethyl, it means that you're going to start with the ethyl before you come to the methyl. Okay, so assuming instead of this H, you have another carbon atom, and then this carbon atom has also its own. So this whole thing is 1, and it is ethyl instead of methyl. Okay, so in naming the thing, we start with 2, and then now the ethyl comes, and then you put the position of the next group that is the methyl part. Okay, at this level, this naming is not really much of the things that we really need you to know. Okay, so it is not a very major concept that we strongly emphasize, but at least know some explanations like the ones I've just provided. Okay, so it will be very helpful to find complex names of compounds, and they give you a complex structure formula of the compound, and then they ask you for the name. But of course, it is always good to know such concepts. Okay, let's look at the concept of molecular and structural formulae of formulas. You can give depending on what you want. If we have methane, that is CH4, that is methane 4, right? This is the molecular formula. This tells us the number of carbon atoms that make up methane. Carbon atoms that make up methane and the hydrogen atoms that make up methane. So basically it tells us which carbon atoms are in that compound. So here we have 1 carbon atom and 4 hydrogen atoms, right? So this is what we call the molecular formula. But how are these atoms, whether carbon or hydrogen, arranged in methane? The structure of how they are arranged is what we call the structure formula. So in this case, you have that the hydrogen, that is how it looks like. Okay, that is how this is the structure formula for methane. For ethane, you have 2 carbon atoms, and then each one like that. That is, so you have the 6 hydrogen atoms. That is methane. Okay, so if they want to complicate things for you, they can bring for you the name just like this, and then they tell you to draw the structure formula. So you should be able to know the rules. The rules are that these numbers here give you the position of the branching, and then this prefix here tell you how many branchings are those, and then this methyl tell you what has branched. Is it a methyl group? Is it an ethyl group? Okay, ethyl means 2 carbon atoms, methyl 1 carbon atom. Okay, and then the total number of carbon atoms, pent. So let's look at another concept that we also looked at earlier on and see how it comes up. So here, in alkanes exhibit isomerism. Okay, what isomerism means is that you will have the same molecular formula, but the arrangement of the atoms is different. Okay, you have the same molecular formula, but the arrangement of these atoms is different. So let's take this. How many carbon atoms do we have? 1, 2, 3, 4, 5. So what you basically have is C5. How many hydrogen? These ones are 3. 4, 5, 6, 7, 8, 9, 10, 11, 12. H12, right? But can we rearrange this? Do you know that you can pick this and put it here? C, like that. And then this H, you bring it here. Do you see that it now looks different? Yes. This one has moved away, this one has moved away, and it has been placed here. But the number has remained the same. The molecular formula here has remained the same. You can move this away from here and put it here. And move this and put it here. It will also look different, but this one here will remain the same. The molecular formula is the same, but the different way of arrangement of the atoms is going to be different. That is what we call isomerism. So these different ways of arranging the compounds that are made because of the different ways in which these atoms are arranged, these are the ones we call the isomers. The tendency for compounds to have different arrangements of atoms with the same molecular formula is what we call isomerism. We have been talking about alkanes. Where do we get them? Actually, we can get alkanes from what we call natural gas. Natural gas is made from organic matter. That means that you can actually prepare some of these gases even on your farm where you have organic matter. But also during petroleum refinery, you will have a number of different alkanes being produced for different purposes. The process usually used there is what we call fractional distillation, and we shall look at that in a separate topic called petroleum. So alkanes, we say that there are very many depending on the number of carbon atoms that they have. So far we already know methane, we know ethane, we know propane, we know butane, we also know butane, right? The one with 5 carbon atoms. But we can have those that have almost 16 carbon atoms. Okay, so that means that we have very many of them, right? Now, what are their characteristics? Remember, we say that generally they are very inactive. Okay, they are very inactive, and that inactivity, or they are not generally reactive. That is because of the way they are saturated, right? They are saturated. So the first 4 alkanes are gases, but after that you have liquids. Okay, after that you have liquids, and then you have those that are more than 16 carbon atoms. The ones we are calling the higher alkanes, they are actually waxy solids, right? Waxy solids. So alkanes can be extremely very long with many number of carbon atoms. They are generally not soluble in water and also less dense than water. This can mean that the gaseous alkanes can actually be collected over water, okay, because they are not soluble in water, and also they are less dense than air. And then the more you have a longer chain of these alkanes, the more you're going to have increasing boiling points and melting points. So the more you have carbon atoms, the more the boiling points increase. But methane, which is the first the first compound, is basically colorless, it is odorless, slightly soluble, a little bit, but we can still collect it over water, less dense than air, stable, and generally in the laboratory we make methane by heating a mixture of sodium ethanoate or sodium acetate, if you can call that, and sodium hydroxide. You heat this and you collect methane here over water. Okay, that's how you can prepare it similar. We say it is not very reactive, but there are two major reactions that we can talk about. Combustion, it's reaction with oxygen. It reacts in two ways. In plenty of oxygen, you form carbon dioxide and water. The reaction produces heat. And then if you have limited oxygen, you produce carbon monoxide, water, and also some heat. And the second reaction is what we call chlorination, the addition of chlorine. Okay? And this reaction can happen under sunlight. You will form chloromethane and hydrogen chloride gas. When we look at the petroleum or what fractionally distillation in the refinery, you realize that a lot of these products are actually alkanes. Issues to do with coal gas, bottle gas, natural gas, all these are actually alkanes that can be used as fuel. Okay, and then in manufacturing, alkanes can also be used. Methane decomposes at 1000 degrees centigrade to form hydrogen and carbon. Okay, and carbon black. These are actually used. These are used in making ink, paint, and carbon papers. Okay, so that marks the end of our second session on organic chemistry. We have been looking at alkanes. The alkanes are called saturated hydrocarbons. There is only a single bond between the carbon atoms, two carbon atoms. There can be several alkanes depending on the number of carbon atoms that they have. Okay, they can also be long chains, straight, or they can be branched, and this gives us issues to do with how to name them. Okay, the naming can depend on if we have a long chain, and also the naming can depend on whether we have some branching. If we have some branching, we need to indicate the position of that branch, what has branched, and how many branches are there. So that's when we put the position of the carbon atom from which the branching has happened. And if the branchings are many, then we include some prefix. For example, di, tri, tetra, and then we indicate the positions. And we also need to name the group that has branched. Is it a methyl group? Is it an ethyl group or another group? Thank you for listening.